Hello everyone and welcome to this video. This is my new channel Slavic Codex where we are going to learn about different technologies and stuff that I am curious about. Today we are talking about data modeling and why data really matters in our application. It's even more important than the application itself because we can rewrite the application but we cannot restore the data in some ways. So there should be some defined ways in which we define schemas and objects that we are going to include in the database. And that's what we are going to talk about in this video. Also about the different types of databases that we can use and the tweaks that we should note about each of them. So without further ado, let's get started. As you might know, every system stores information, transforms and retrieves data. So here we are looking at some entity relationship diagram as it says above, and we have several entities. What's an entity? You can look at it as an object where we define the schema of our data that we are expecting to have for each object. For example, here is some shadow copy of the Instagram database model, and it's just a dummy one, but it's simply a node that you can imagine what happens behind the scenes. Here is the follower entity. We have the user, the media, the post, and the comments one. Each of them has defined roles, and they are also connected to each other. This is a great example of a relational database that use SQL under the scene behind the scenes, sorry. It is defined by having a primary key, which could be an ID, for example, like in the user. And we also have foreign keys, which serves for connecting one entity to another. For example, we could have a post, which has user ID, which is connected to the ID of one of the users. That's how we differentiate who have post the exact post and stuff like that. So why data modeling is so important? Because as you can imagine, this is the core of every application. It could be Instagram, it could be a banking app. There you could have transactions and other other data. Or if it's store where you can sell something, you have orders, you have purchases, and stuff like that. So we can move on and check for other instances for relational databases that use SQL. They all use SQL. Other examples are PostgreSQL and MySQL. These are instances that provide open source solutions that you can use. There are also some enterprise one, but we are not going to talk about them in this video. Um, Here I have a diagram, which shows the difference between the SQL relational databases and these that don't use SQL. So the main differences that, as you can see, one are relational and the other one are not relational, and how that affects the data. As you saw in the previous example, in the relational database, we have um, instances, for example, IDs that references object from another entities. That's how we connect our data. But in the NoSQL databases, we have other solution. We have the graph databases. We have key value and column and document solutions. These are different type of databases. For example, key value is known for easy retrieval, and also that the data is not related to each other. There is not some kind of best database, they all have some advantages and disadvantages, as you can imagine. For example, the disadvantage of key value database is that you can hardly query for any data. It's designed that even the value is opaque to the system. You don't know about the value, and for example, if you want to search for it, you should enter the key value, and that's something that is solved in the SQL, for example, where you can query for objects and where some certain condition matches. For example, there you have the column store, there you have the graph, which is the opposite, which have the opposite design of the key value because it strongly um, relies on the relationship between the data. As you can see, one simple example is if you have, for example, um, entity company and then the entity country, and you want to search for which, for example, companies have offices in X country. And it's going to be quite optimized to search for that, as you have this many connections between the different entities in the database. Then you have the document database type, um, which is also famous. For example, MongoDB uses um, that type. It also has connections, as you can see, but they are not relations in the same way as SQL, because in SQL there are different tables that reference to each other, while in the document you just have different objects connected to each other. And one thing that differentiates them. For example, if you query an API, it's more likely to return nested objects between each other. It will look something like this, like a tree or something like that. So that's why code implements behavior and data defines reality. Okay, so to summarize this, we should be careful how we define our data, because later on it could include problems, for example, about scalability and stuff like that, because each database has, you know, advantages and disadvantages. I'm going to link that blog into my video so you can check out. We can even go through. It has NoSQL, SQL explained. If you design your data carefully, your system will become more stable, more mature. Because as we know, we want to protect our data. We want to take the right decisions from the start, because later on it could cost us more to re-architecture what has been already implemented, and in some ways there even could be some losses of data, which could be really painful in some points. So thank you very much for watching this video. If you enjoyed, if you learned something, please like and subscribe. Leave a comment below what you want to watch in the upcoming videos, and see you in the next one.